Hello, this is GregSowell from GregSowell.com, 3G Networks, and this is my Mikrotik security class. I'm going to keep this one nice, short, sweet. It's really going to be focusing on the introduction to kind of security features you can implement and sort of some best practices as far as security goes. So, getting started. IP services. I'm not going to stick too close to these slides because there's a subset of things I always make sure to disable by default. Because by default there's several things that are on. Usually I go to IP services right here, and I kill FTP, SSH. I kill telnet. Generally I only winbox into these machines, so I just leave winbox on. Now another thing to note is if you do want FTP, this is just kind of a by the by. If you do want FTP access on, you can do the available from, or in the firewall, you can make a specific firewall rule. But you also have to remember, if you have, say, one public IP on the outside, that's all you get, you're doing NAT overload or port address translation of that, and you have an FTP server on the inside of your network. Well, you want to NAT FTP in. If you don't turn off the FTP service right here on this guy, or change it to an alternate port, he'll catch all your FTP requests even though you put in the natting to NAT to that inside host. So that's one thing to keep in mind. It's the same with web, because by default this guy's running a web server. And so you can see by default this mask of 000/0 means any address can connect. And so generally you're going to want to come in here on this guy and available from, put a management range of IP addresses. If you have multiple ranges, you're going to want to do that with a firewall rule itself, but we'll get to that later. Let's see, so that's killing our IP services. Next, I generally go down to Tools, Bandwidth Test Server. Now this guy's enabled by default, as you see, but he's got authentication enabled, which means you have to use a username and password that's within the system that's allowed to access this. So people aren't really going to be able to jump in and connect to you, but it will still show up. Whenever people are doing port sniffing, it'll still show up as TCP connection attempts. Authentication failures for this, and so the first thing I do is go ahead and disable that guy as well. Another security procedure you can use is IP neighbors. And what this does is it's very CDP like. I know Mikrotik does run like CDP version 1. So what this allows you to do is, you can see I've got another Mikrotik on my network that's got neighbors enabled and allowed. And so for any untrusted networks, like my outside interface going to the internet, generally you want to disable that protocol, just because it's another theoretical entry point for somebody. You want them to be, you don't want people to be able to gain any intel on your equipment if you don't absolutely have to let them. Boop. So let's see, let's hop back over here to the slides and see what we got. Killed that. System users. So another thing we can take care of right off the bat real quick is actually whenever you get a fresh machine, the username is admin with a null password, and so the first thing you want to do is set up a new password. After you disable those services, you want to set up a password. System, I believe it's users, there we are. So this is a method to allow you to create multiple user accounts that have different levels of access, different passwords, obviously. Group, you can set up multiple groups and specify which specific services they have access to, right there. System user, system logging log. Move to that next. If you want to look at the system log, you can click log right there. And as you can see, it shows you all kinds of information that scroll through there. Well, if you want to manipulate what information actually hits, go system logging. It'll actually show you all the default stuff. Echo means to new terminal, so when you open a new terminal, it'll show that stuff up there. Probably if we open this, it should say, yeah, system rebooted without proper shutdown, probably power outage, blah blah blah. That's going to be your stuff going to echo the critical stuff. Error info and warning, those are really great ones. Additional ones that usually I add, because I do a lot of IPsec, is whenever I'm debugging anything IPsec memory. Okay. Right. So anything IPsec related is going to hit that log and disable that. Another rule on all of my Mikrotiks I always add is UPS with a twist, because I don't ever actually hook up a UPS to any of my systems. You hit that little tick right there. It says not UPS action. I want to go to remote. Okay, over here on actions, here's the remote action that we specify. And what I'm going to do is I'm going to put in the IP address of my cacti-easy server. It's running syslog collection. And so within there, I actually do alerting. So if I get a failed user attempt, or say I'm doing some DHCP snooping or some testing, to see if somebody's running a rogue. Excuse me. If somebody's running a rogue, it'll dump that information, and I'll be able to alert on that. That's another great security feature. Anytime somebody's trying to brute force your system or anything like that, you accidentally forget to, disable FTP, or for some reason somebody's trying to break into your FTP, you can quickly get an alert on it. So this is going to be the basic diagram, and I'm going to toggle over to another diagram as we go through some of the configurations to show you just our basic configure, how we're figuring all this stuff. Ethernet 1.1.1.1/30, Ethernet 2, 192.168.1.1, and that guy's a /24 subnet. You got a PC and a web server. Pretty straightforward. Probably what you're going to see at most small offices, whatever. There's probably going to be another router out here off the internet connection, and they'll be doing an IPsec tunnel, a secure tunnel. Excuse me, I'm on the tail end of a cold. Yeah, they'll be doing an IPsec tunnel in between the two right there. So moving on, packet flow. And I'm going to switch over to my browser for this, because whenever I blatantly stole the picture, you do see that I referenced where I got it though. I stole this picture from Mikrotik. It didn't really translate too well. So why am I showing you packet flow? Because in this example with some firewalling, I'm going to be doing Mangle rules. And what Mangle rules, well, the way I'm using the Mangle rules is I'm actually going to mark a packet. So I'll take packets as they move through, as they start traversing the router. I'll mark them and say, this is X type of traffic, and then this is Y type of traffic, and I want to drop all of X type of traffic. So you have to know where in the flow all this stuff happens. And if you jump to the Mikrotik website like I did, they've got the packet flow diagrams here, plus at the bottom they've got some examples that are terrific as for IPsec. They show you the flow as it goes through, because it has to go into the router and then encrypt and then head out the door, all that good stuff. I'll reference back to this guy when we do an actual Mangle rule. And so getting into the meat of it, PAT, port address translation, what does that mean? That's like NAT overload, or all of your privately addressed hosts on the inside natting to a single IP. And that's going to be, let me pull up the diagram, here you go. So all of the addresses in here are going to NAT to this 1.1.1.1 port address translate. And I explained that in my intro to networking class, so you guys can jump on there, and I'll have a little bit more detail on how the natting actually works. But port address translation, kind of in this security context, does give you a little added benefit on the security side, because people on the inside can initiate connections out on the internet. If there's a web server right here, if there's Google right here, and you want to hit it, you'll go through here, you'll pat to that address, you'll hit Google, return to this address, and then translate back to your private address. Now if Google wants to, just of his own volition, initiate a TCP session into you, he'll try and go to this address. Well, it wasn't created, it wasn't initiated by somebody on the inside, so it just gets dropped. So it does give you a little bit of security there, and the inside has to initiate the connection for it to work. So that's, it's a benefit you're not always going to want to do NAT. Most of the time, at my apartment complexes and places like that, we do natting just to save on addressing, but some people give publics to all their apartment users, something like that. In that case, you'd be just straight routing right through, and so you'd lose that that added benefit of connections only initiating from the inside. You could do something with TCP from the outside coming in, but you couldn't really do anything from the UDP's perspective. So let's see. Firewall filter. All right. This is what it's really all about, making firewall rules and how it works. There's 3 chain options. So whenever you go into your Mikrotik, which I'm going to do really quick just to show you where that's at, and there's a lot of power in IP firewall because there's more than just firewall, and that's where your NAT rules are, your Mangle rules, and several other things we're going to touch on here. But filter rules is what we're talking about right now. So click the plus to add a filter rule. Let me expand this a little bit just so I can get all my rules in there, or rather all my options. So chain, what does that mean? What does chain mean? You've got 3 options there: forward, input, output. Well, when I was brand new to the Mikrotik OS, I looked at that and I said, okay, input's going to be people trying to bring information into this router interface or into my router, and then out, to traverse through, and then output's going to be heading out. Because when you come from Cisco, whenever you apply an access list, you apply it on an interface, incoming or outgoing or both. So this doesn't really apply because this is more of an IP tables type of terminology. Input means traffic from some other source directed straight for the router itself. So in our little diagram here, that means if this guy wants to winbox into this router, he's going to go through the input chain because he's going to be connecting straight to the router. He's not going to try and pass through him to go to the internet. He's going straight to the router. That's the input chain. Now the output chain is the complete opposite of that. Anything that was sourced from this router that wants to go to a host is going to go through the output chain. Out, out, out. So this is going to come in to the input chain if I'm this PC over here, 1.2, and I'm winboxing in. Well, when my traffic's going to return from that router, it's going to go through the output chain. So 99% of the time your rules are actually going to be in the forward chain. Up here, the forward chain means anything moving through the router. So it's sourced from somebody, back to our diagram here, sourced from somebody on the internet, moving through the router and then going to the host. That's forward chain. Anything from the host going out to the internet, that's forward chain. So anything that moves just passes through the router, forward chain. So most of our stuff's going to happen in that forward chain right there. Let's see here. Action options. So this is going to be more or less, what do you do with the information? Once you build your rule set up, what are you going to do with it? And actually, there's 10 options. There's a lot of options. I'm only going to touch on a few right here. Except means as you're moving through a list of rules, you start at the top. So if we had forward, that's going to be accept, that's fine, accept. Let me make a few. They're all going to be the same. Just so you know. This will help. So these are all accept, right? So what this means is the way the rules work is you come into the top of the rule, the very first rule, which is rule 0, and you check your packet against this. It's a set of matching. Is it sourced from this place going to this destination, these ports? If it matches, it'll stop right there and it won't continue on. But if it doesn't match, it'll skip on to the next line, tries to find a match. If it doesn't, it keeps skipping down, just keeps working its way down the list. So if for some reason there's a piece of traffic that you want to just stop and not continue down the list, or it's almost like a bypass of the firewall rules, if you want it to not be affected by any of the rest of these rules, you can just accept the traffic. So that would be action accept right there. See, these are the rules. Here's the general, where you set up most of your stuff, most of your rules, your matching statements. Advanced, this gives you a little bit more power. and then actions right here is what we're talking about. So if you want the piece of information moving, or this packet moving through the firewall rules to just stop and not really have anything happen to it, accept is what you're looking for. Moving back, add destination to address list. This is an interesting one. I use this occasionally. That would be add destination to address list. What that means is whatever the destination address is in that packet is going to get added to an address list. And we haven't talked about address lists, but they're much the same in theory as a Cisco address list. You know, it's just a bunch of subnets or individual hosts in a named list. You know, so a list of addresses. Other side of the coin, add source address to address list. Easy peasy. Whatever the source is, just add to this address list. Another cool option with those is you specify what the address list name is, but you can also give it a timeout. Excuse me. So you can have it permanently stay in that address list by specifying no timeout, or you can have it actually time out after X number of hours, minutes, or seconds. You know, if you want to affect this traffic only for a short amount of time, you know, some pattern looks like a denial of service or something to that effect, you can add them to an address list that black holes their traffic, you know, just drops their traffic for X amount of time, or add them to an address list that will half open a TCP session for a short amount of time. And I'll talk about that in just a second. Drop. When I'm using firewall rules, that's what I use most often, is drop. So that would be right there, and that's just going to take the packet, throw it in the bit bucket. It's not going to send back an ICMP message saying, oh hey, you know, this got dropped or it's unreachable or anything like that. It just drops as if, you know, as if it never existed. Log. I've used this one before, and in our example we're doing some firewalling for here in a minute we're going to do a firewall rule example for port 25, you know, SMTP traffic, and I've had an instance before where someone had a virus where a specific machine inside was constantly sending out spam, you know, SMTP port 25 out to the internet, and they only had one server that legitimately needed SMTP. So what we did is we allowed it to that one server. Next we added a block rule, and you're going to see all this in a second, but to figure out which machine was actually sending out the spam, we added a firewall rule that basically said log. So anytime this user on the inside tried to send out, you know, all this spam to all these crazy SMTP servers, it would actually dump an entry into the log. So it was really helpful on pinpointing who that was, log, and then you give it a log prefix. So you could say like creep with virus, you know. So if it matches that port 25 stuff, it's the guy with the virus. Tar pit. This is an interesting one. This is usually used with people trying to DOS you or something like that. As most of you guys know, how the three-way handshake works is, I say to you, hey, I'd like to open a session. You acknowledge with a SYN packet, and then I acknowledge that, and that's the three-way handshake, and we're good to go. We're rocking and rolling. So what a lot of like say script kiddies do and stuff like that is they'll hammer you, you know, repeatedly, you know, just trying to open as many sessions as they can, junk like that. Or, you know, if they're well, that'd be more of a denial of service. What they're really trying to do is say crack a password, something like that. You know, they keep making sessions over and over and over, and then they'll try a password disconnect, try another password disconnect, you know, that kind of stuff. So what you can do is you can tar pit those guys. And what tar pit does is that'll go ahead and complete the three-way handshake between the router and the attacker. It won't ever actually go to the resource they're trying to hit, and it'll just hold that TCP session open. And so their scripts will just keep banging away at nothing. You know, it'll actually be trying to authenticate with the router, and so their script will have to just time out and then restart. You know, and so it'll basically kill their script. So that's what the tar pit does. So let's see what we got now. allowing specific SMTP outbound. And so let's see what IP we used in this guy. I had to have allowed one specific guy. Alright, so we'll use this diagram here and we'll pretend that there's a web server right here is actually running FTP as well. So 1.3 is who we're going to send it to. So I'm going to go ahead and get rid of these rules really fast and start fresh. So clean slate. So here we go. So first what I'm going to do is I'm going to do an accept, because I want to specifically allow, or actually never mind. We're not going to do it to 1.3 because we're on this inside subnet, and out here we've got let's say it's 2.2.2.2. That's our FTP, or rather our SMTP server out here, which is going to be our email server. And so we only want our users on the inside to be able to go to 2.2.2.2. That's the only person we ever want them to be able to go to for SMTP. So I'm going to first do my accept statement. So I got action accept forward chain, because it's traffic moving through the router. Source address is going to be 192.168.1.024. That's going to cover the whole subnet. Going to single host 2.2.2.2 protocol is going to be TCP. Destination is going to be port 25 for SMTP. So let's read it. Source, anybody on the inside, that covers the whole subnet. Destination 2.2.2.2, which is our legitimate SMTP server. Source port TCP port 25. So that's SMTP. Action was accept. So we say OK. So that's going to go ahead and add it at line 0. So I'm going to get plus forward chain. Now what I want to do, I want to say anybody, and I can rebuild it just like I did there, or I can open the old one and I can say copy, which is a great feature of Mikrotik. So it'll just make a copy of that rule. I'll change the action to drop. So now I'm saying anybody on the inside, and I can say going to 0.0.0.0/0. You have to remember to add that /0, otherwise it means a specific host. If you say /0, that means any IP. So let's read it again. Anybody on the inside going to anybody on the outside, source protocol, or rather protocol TCP, destination port 25, and action we set to drop. So we'll say okay. You can also, if you just blank it out like that, and remove it, that's the equivalent of any. So we said okay. So now we've got accept anybody on the inside going to our legitimate specific SMTP server, port 25, allow it. Anybody on the inside, forward chain, moving through. Anybody on the inside heading to any address on port 25, drop. So order of operation is start at the top of the list, work your way down. So we're trying to send legitimate email port 25 to our mail server. It'll accept. If I've got a virus and I'm trying to send to somebody else, I'm trying to spam out, it'll hit this address right here and say okay, because generally that viral traffic's going to just try and connect straight to their mail servers themselves, from your PC to their mail server. So it won't match this rule because it won't be going to our mail server. So then it'll try and connect to anybody else's mail server. It'll fail and drop. So you basically protected your inside, your juicy middle, from getting a spam virus. Excuse me. Some organizations will have, a mail server inside as well, and you don't want to get blacklisted because one of your users, is sending out spam coming from your subnet. That could be bad. So this is a good way to protect yourself from that. So like I said earlier, this rule right here, the log rule, if you wanted to try and figure out, so you did have a virus, you mitigated it, now you've stopped it, but you want to figure out who's actually doing it. Which PCs are infected, so you can copy that block rule, the anything, the inside to any. That's what I mean to say. Action. Change the action to log, and we'll say SMTP virus, and then we'll OK. And what you want to do is click and drag that log rule before you drop. See that? That way it'll actually match this log rule. It'll go ahead and drop an entry in our log file, and subsequently actually dump that out to our syslog server, which we can alert on too, if you want to. And then it'll continue on. It'll go ahead and drop the traffic. Excuse me. So that's a basic intro to using the firewall and moving around. Now in here you saw a lot of options. So not only can you use source address, destination address, protocol, source port, destination port, any port, but you also have the option here for like some sets of peer-to-peer traffic. And so you can say, you can see there's a good bit in here. BitTorrent, that's only really going to match the initial session of some BitTorrent stuff, because a lot of BitTorrent these days actually runs encrypted, and so once any information is encrypted, you have absolutely no idea what's in there. So you can say all peer-to-peer, and you can drop that stuff if you want to. You've also got the option for the incoming interface and outgoing interface. So if it's coming in from a specific interface or going out of a specific interface, you can get pretty granular in that. Packet mark, that's going to be the result of a Mangle rule, which I believe I have in the slides coming up. If not, I'll go ahead and show it to you. Connection mark, that's going to be another one. That's going to be another Mangle. Connection type and state. This is going to be like establish, invalid, new, related. Let's see, for connection type, you've got a few sub presets, already in there. Let's see advanced. There's some interesting stuff here. This is where you're going to use your address list. So if you have an address list and you want to specify it in a firewall rule, you can do that there. Layer 7, we're going to talk about that in just a minute. As you can see, you just got a lot of other options. Great stuff in here. So your firewall rules can be pretty granular. You can be pretty granular with those guys. They're awesome. Ranging rules, we talked about the order of operation. You can drag and drop them to move them around. And I believe you can do blocks of them at a time too, if you wanted to, hold control and click and then move them up down, so you can drag an entire block of addressing around. Rather, not addressing, a block of rules. Address lists, we had talked a little bit about that. For firewall rules, adding to address list right here if you want to just start making them. Address list, we'll just call it 1. See, simple as that. You can just make a whole bunch of address lists. You want another address to be in the same address list, you just give it the same address list name. That's all you gotta do. So I'm gonna copy that one just so I don't have to retype the name because I'm lazy. Excuse me. There we go. Easy peasy. And in these you can also 192.168.3.0. You can specify subnets as well. And so not just single host, but entire subnets as well. Those can be useful, and you saw in firewall rules, and you can also use them in Mangle rules. Layer 7 matching. Now I'm no regex guru, but I can kind of get my way around, and I've got some tools. There's a great little tool called Text Crawler that's completely free, and it'll actually let you put in test information, and then it'll let you put in regex statements, and it'll see if that test information actually matches. And that's usually where I build most of my regex, just to make sure I'm doing it right. But I've got one right here that I'll show you how to put in and kind of use. And I use this on my website for blocking access to my WordPress admin section and login section. So unless I specifically allow you in some form or fashion, you're not going to be able to get into my blog. And so this caret right there means beginning, $sign means end. Yeah, I'm not going to explain to you regex. I'm sure you guys know that. Period asterisk means anything there. Get, because I'm looking for get requests. So it's going to be when you're actually making a get request to my website, it's going to be checking, are you trying to go to this WP admin section or this WP login section? If you're trying to get to either one, that's what the pipe means. So I'm just going to copy that. I'm going to come back over here to my router, layer 7 protocol, add. I'm going to drop it in the regex, and I'm going to name this block WordPress admin. Yeah, I try and get as specific as I can. Block WordPress admin, and then back in our filter rules, let's just add another rule and say forward. We'll say, if it's a our web server right there, anybody heading to 101.101 protocol TCP destination port 80, and you are advanced layer 7. You're trying to get to block WP admin. It'll run that regex against this traffic. So first it'll match this stuff right here, destination 101.101, which is the outside interface, which I will be natted to. Let's see, yeah, because my web server right here, people on the internet are going to try to hit 101.1. They're going to nat in port 80 to come over here. So their destination address is going to be 1111. If you're heading there, port 80, then TCP. Then you're going to additionally check layer 7 protocol. If they're doing a GET request there, I'm going to drop them to keep you guys out of my website right there. And another great thing is right here in the firewall rules, you can add a comment. So block jokers from WP admin login. So I highly recommend adding comments whenever possible. Not only for your sake, because you're not going to hit these firewall rules all the time, so this makes it a lot easier to just jump for blocks of code, but also if you ever have a problem and you do a support file, you send this to Mikrotik, the comments help them figure out what you were trying to do. So if you had a problem, it'll help them fix it quick. So that's kind of how the layer 7, it's going to jump into that data portion of the packet and just scan through there and see if it matches regex. It's incredible. We use it a whole lot for doing all kinds of filtering and protection, and I use it personally for my stuff too. Let's see, bridging. I guess we're going to talk about bridging. Before we actually get to bridging, I don't have it in the notes right now, but I'm going to update the slides to add a little bit to it for Mangle rules, because you can use Mangle rules in your firewalling too. So Mangle sets up almost just like the firewall rules do. And I'm just going to briefly go over these because I'm going to get more in depth on them when I do a quality of service class in the future. But you've got far more options here, and this is where the Mikrotik packet flow actually comes in. There's several places. Input output, that's going to be the same stuff heading into the router, specifically sourced, or rather destined to him. Output's going to be stuff sourced from him. Forward's going to again be stuff moving through the router. Post-routing and pre-routing, these are new ones. Pre-routing is going to be as stuff kind of just coming in and then hits forward and then goes post-routing. But at what point do those happen? And and what other things can affect them? Because there's a lot to it. And that's where this packet flow is just incredible. Whoever did this did a fantastic job. I think it was. I think it was Giannis who did it, not the sales Giannis, but the other guy. He's terrific. I believe these are his. But you can see this is going to be the bridging one right here. So if you're just doing kind of a bridge or bridging firewall, which we're going to talk about in a minute, that's the packet flow you're going to be looking at right there. Right here, if you're doing routing, this is the packet flow you're going to look at, which I'm going to assume you're doing. Input interface is where the good stuff comes in. Incoming interface, is it in bridging mode? Yes, go that way. No, go this way. So you can see that you hit pre-routing first, keep trucking, then you make your routing decision. Does it need to go into the input? Then you cut in, right? So if you're doing, and at the very bottom they show you the IPsec flow. And so if you're actually doing IPsec encryption, instead of hitting the forward next, it actually goes this way, comes down into the input chain, and then starts moving along from there. So that's something to think about when you're marking stuff, because if you're trying to mark something and apply a policy to it at another place, you got to make sure that your order of operations right, because otherwise you're filtering or queuing, or depending on what you're trying to do with it, just may not affect. It may not work. And so this gives you a great idea of the actual flow through the device itself. Mostly used in quality of service, but again, if you're doing any Mangle rules for firewalling, one way or the other, it's a good tool to have. And so Mangle is going to allow you to mark packet, because there's a lot of options in here. I'm just going to talk briefly about mark packet, because that's going to be kind of what you do in quality of service, or if you're going to mark packet or add to destination, add to source. If you're going to mark a packet and then use it in a firewall rule, as in mark packets to drop, or you can also mark routing to throw it in an alternate routing table, but that's beyond the scope of this class. And so that's really quickly what a Mangle rule kind of does. So let me move back here, and then with the Mangle rule, I'm just kind of trying to introduce you to the concept, not really teach you how to use it just yet. Like I said, more in the quality of service. So bridging interfaces. The intro, or rather the basic Mikrotik, shows you how to set up bridging and all that good stuff. So I'm not going to go over that a lot, but there is an option to do firewalling on your bridging. So you could have a bridging firewall is ultimately an invisible device that can do filtering, which is pretty cool. So if we have a bridge settings right here, use IP firewall, and this will crank this guy on. Boom. And you can have it actually firewall for VLANs as well as just traffic moving through your bridge. So you just enable that, say OK. And now in theory, let's move back to this diagram and kind of use them as a rough theory. If this Mikrotik, say this is this right here, this is all one subnet. Let's just say this is all one subnet. These are our database servers, and this is the rest of the server subnet. And we want to protect those guys, with some additional firewall. You can drop a Mikrotik in here and bridge two interfaces together, Ethernet 1 and Ethernet 2, and actually apply firewall rules right here in the middle. So even though all of these devices are on the same subnet, as it switches or bridges through, you can actually have these firewall rules take effect, and that's where your incoming outgoing interface options are going to be kind of a big deal. You want to make sure that traffic sourced from or incoming into this Ethernet interface, moving this direction, gets filtered in such a way, and then vice versa. So that's really cool. So you can drop in a bridging firewall in a network, and nobody will even know it exists or is there. It could just be a quick blip, and then it's there, and you're filtering. You'd either want to be on that same directly connected subnet to MAC telnet into it, or have another Mikrotik on that subnet that you can MAC telnet through, or you can put an IP on the bridging interface itself, or if you've got like an RB 750 like I'm using here for this example, you could bridge ports 1 and 2, have the bridging firewall move through there, and port 3, 4, or 5 be the management VLAN, or the management interface, and just actually put an IP on that and go that direction. to get into this guy. So let's see, moving on. Rogue DHCP detection. This is a security class, so it's another security feature. IP DHCP server. I'm sure all of you guys intimately familiar with that. Alerts. Now, if I have a DHCP subnet, interface 2, the one that's 192.168.1.0/24, I got a DHCP server running in there, okay? And I'm handing out addresses. And I want to make sure that there's no rogues out there while I can enable this alert, right? And so what it basically does is it kind of sniffs for rogue DHCPs, and on alert I can perform an action, and so I can just pop a message into the event log, and then that'll go back to my syslog, and it'll alert me, and I can take care of it from there. And so that's good. The only thing is it gives a lot of false positives. For some reason, Microsoft, like little Soho wireless routers, who knew they even made them, often, well, almost without fail, will give a false positive. It won't actually hand out IP addresses on that internet-facing interface. They've got everything plugged in properly, but to this alert mechanism in Mikrotik, it appears that way. So due to that fact, I quit using these. So what I do now is, if interface 2 is the one handing out IPs, I'll go DHCP client, and I'll add the DHCP client to that interface. And what I'll do is I'll get rid of use peer DNS, peer NTP, and definitely add default route. Because if you let your Mikrotik pull a default route from this other guy, by default it's going to come in at distance 0. Your static default route is going to be at 1. So guess what? You're going to black hole all your traffic. So what you want to do is get rid of that add default route. So all I'm doing is I'm accepting an IP address on that interface, because most rogues are going to be in the 192.168 range. So generally at our apartment complexes, we're going to be in one of the other RFC 1918s, 172s, or a 10 subnet, because most people you're going to use your 192. It's generally people plugging in their Linksys routers backwards. So it's almost always going to be 192.168.1 or 0 something, So if you just tell this guy to sniff for an IP address on that interface, there's an alert, and if you look on my blog, you'll actually see the alert in the syslog. I've got a little syslog section in there of the alerts I have set up in my syslog, and so whenever you pull an IP via the client, it'll dump a syslog message back, and then it'll alert you that there's a rogue, and it'll tell you the IP address. You can come and cross-reference. IPARP, you can come and cross-reference his IP his IP address in the ARP table, look him up, shut him down. So that's a really good way to look for rogues. And that's the preferred method I use. I've found, because it never gives a false positive. If you get and bind an address, you get an alert. If their DHCP is not really handing out addresses, no alert. So that's the rogue DHCP. SSH tunnel. This is more of just kind of an interesting thing you can do. You can open up PuTTY and SSH to your Mikrotik. Let me put an IP on this guy really fast, and I'll show you what I mean. So I'm going to go IP DHCP client. I got him plugged into port 2 into my little test network here. I'll go ahead and get rid of default route, because, oh no, I'll leave it in there. Searching bound. Let's see what we get. 102. So here we go. It's going to be 192.168.222.102. Oh, That's right, I turned off SSH. Let me turn that back on real quick. IP services. There we go. See if that lets me connect. Should be admin. There we go. And so now that I'm connected, what I can do is in PuTTY there's something called SSH tunnel. Change settings, SSH tunnels. Now what I can do is I can tunnel a local port from my machine and have it spit out at that Mikrotik from his address on whatever port I want. So if there's, I don't know, an RDP server, or let's say there's RDP is a good one. If there's a web server, so there's a web server that's only accessible on the inside over there and I want to get to it, I'll say source port 80, and let's say the web server on the far side is, just for fun, say it's 192.168.1.3. I think that was the one we had in our demo example, and I'll say :80 because that's what I want to spit out to. I'll just say add and apply. Now what I do is open a web browser and I browse to http://127.0.0.1. So what that's going to do is that's going to try and hit myself, because as soon as I applied that SSH tunnel and I told it local source port, PuTTY starts listing on port 80. And so if I try and browse to this address with one of my browsers, Internet Explorer or whatever, it'll actually take that traffic on the local machine destined for itself, and then boom, it'll shoot it through that SSH tunnel, hit the Mikrotik, spit out of the Mikrotik, and destined for that private IP address and private IP destination address that I specified. So it's kind of a little pseudo backdoor. So if you don't want to VPN, if your security policy dictates that you can't VPN into a device, this is kind of a little backdoor that you can do. And this is possible on most straight Linux boxes, since this is a Linux kernel this guy's running. You can actually do this. So let's see, what else do we have in our list of slides. Oops, that's the packet capture. And then just some resources, some additional information on my blog. It's got my blog, a link to me, a link to my sort of like online resume, because I do consulting as well, and also a link to Cacti Easy. I highly recommend Cacti Easy. It's the monitoring tool that I use. There's a lot of I think Fortune 500 companies that use it. I believe Comcast even uses it for their infrastructure. And then I think Ford Motor uses it, or at least did use it at one time. I'm not sure if they still do. There's a couple of years ago that I heard that they used it in their infrastructure. It allows you to monitor everything from hard drive utilization percentage, per partition on your Windows box, Windows services, all the way down to how much toners in your cartridges, and an alert on all that stuff. Build weather maps, see the arrows between all your sites, how much bandwidth's moving through. I monitor some of my generators with that stuff. Yeah, so that's another tool that's in the references that's listed there. If you have any questions or comments, please drop them in the appropriate section at the end of this video. And thanks for watching, guys.